This is the stereo microphone preamplifier that I've been working on for a long time. This is currently March 13th on the calendar. This is why I'm starting this video, and as this video progresses you will see the project digress. I start this video showing you a working example of where I'm at right now, and this is working very, very well. I only have two microphones sitting on top right now, and it's definitely picking up the noise because they're sitting on the panel. However, it's just a good way to test this real quick to get enough people interested, hopefully to watch the rest of the video, because I go through a lot of details about how this is built and where I'm going from here with this and what I'm going to use it for. So if you're entertained by this, please enjoy the view and stand by. Hello everybody. If you're watching this, that means you already watched the first part of this video, where this project is basically already completed. However, this is where I'm currently at right now as of recording this video. So what I have done here, I've done quite extensive modifications to my original plans. I added output transformers along with input transformers. These output transformers came from the same preamplifier boards out of the Gates audio console. These particular transformers happen to be A0-10427T. So have fun trying to look that one up. They're interesting because they're supposed to go from a high impedance to a low impedance, like a tube plate output down to line output 600 ohm. They also have the ability to drive 150 ohm. And the 150 ohm is wired in parallel, I believe. So what I did is I'm using the two parallel lines as individuals for a 1-to-1 ratio, or the high impedance line to the low as a 10-to-1 ratio, if that makes sense. And by doing so, having the 10-to-1 ratio along with the 1-to-1 ratio on each one of these transformers, I wired up a switch, which is a pad switch, which simply selects 10-to-1 or 1-to-1 on the transformers, so that these transformers can either drive microphone output or line output. And along with that, I also wired it up so that we have unbalanced RCA outputs, and then we have balanced outputs which can be used for microphone outputs or line output if I want to. And with the balanced outputs, if you were to short one of the rings on these, this simply switches it over to unbalanced. So now I have balanced outputs and unbalanced. Along with the input jacks, I did the same thing. So these are TRS jacks to run a balanced microphone in, or if you use a mono plug, tip sleeve jack, TS jack I guess you can call it. Then it simply sets it up for unbalanced. So that'll be quite useful. I'll be able to use this now that I have the output transformers and the input transformers. Be able to use this whole unit as balanced in and out. So that'll be really nifty for studio use. So all the boards are done up. I got the V meters. There's two of these. We got our power supply unit, which is actually a boost buck converter. It converts 12 to 24 volts up to 30 volts and 12 volts to drive the VU meters. So it's a boost buck converter, all fused and ready to go. And the main board that I've been working on that's taken a lot of time. I just finally finished this up. This is the actual preamplifier unit itself. So I decided to go with JRC 2068DD as the chips I'm going to use on this board. There's only two op-amp chips. I didn't use these more serious low noise chips for because it's not necessary, and that's the power supply rail splitter and the one used as a precision diode, or diodes, precision diodes, for the audio limiter section, because that doesn't need to be a high quality audio chip. This needs to, do basic work. However, all the audio chips are going to be low noise JRC, so that will definitely improve the entire thing over what I was trying to do, which was using a JFET input op amp, which will still work. But I think these ones actually have lower noise. I swear I've tested it and recorded it onto a computer, looked at the waveforms, and these just in general have lower noise floor than even the JFET chips I were trying to use. So we'll see how that goes. I got all these little hoops right here, all along here. That's where all the wiring is going to be connected. I did that so that there's no wires hanging off the board until I go to install it. And then once I install the actual board over here, then all our wiring like this can be soldered up to the board. So far so good. It's working out excellent. Now it's just a matter of actually wiring up most of the stuff and giving it a good test. So, quick summary of where this project came from and where it's going. When I started out working on this series of videos, I initially was going to design a binaural stereo microphone preamplifier that was going to be portable use, something pocket size that I could carry with me outdoors or on the field, maybe room recording, to simply just capture sounds and make them sound kind of 3D. And when I was working on that very simple little project, and like I said, that's where this is all started from that, right? Branched out from there. When I started on that, I realized I was going to need some sort of audio limiting circuitry, or possibly clipping circuitry if I wanted to go really cheap and simple. Simple, So when I was doing that, because I realized I was going to need something like that, otherwise the input could be distorted on a recording device from loud sounds being picked up. So that sent me down the path of working on audio limiter circuits. And at that point I figured, let's drop the idea of a binaural portable recording preamplifier and go with a full-fledged actual microphone preamplifier with audio limiters built in. And so that became kind of its own time spent figuring out different ideas and where I might go with that. And one of the things that popped in my head was I had these old audio transformers which came out of a broadcast radio station console from eons and eons ago. And I thought, well, why not utilize these in my project too? So the simplicity, went right down the tubes. It just kept getting more complex and more complex. And then so I decided to add high-pass filtering. And then I decided to add the VU meters. And okay, that's where I'm at right now. I am simply testing one of the VU meters of two that are going to be installed. I have installed a chip down there, an op amp chip, to drive the VU meters buffered so that they're completely separated from the rest of the circuitry for safety reasons, and plus it gives them a nice little boost so they have more variance in the trim pot control to adjust where they should be leveled at. And so that's what I'm currently at right at the moment. I got a lot of the wiring harnessing done and soldered up. Well, surprise, surprise. This is where we're at here. Got the thing all assembled. I've been testing this out hooking my mics up to it and having a lot of fun with two identical microphones like this. Tried it on my ribbon microphone too. It's working great. There's one thing I want to do though. It's a little annoying that I've noticed. The switching power supply right there, DC to DC converter, buck boost converter. It does introduce a slight bit of noise into the circuitry. I mean, that's inevitable because it is a switch mode power supply. However, it's very low, very low noise. And the only way I can show this on the scope is by actually turning off my desk lamp. I tried using fluorescent lighting in here too, and I don't have an incandescent lamp at the moment. So to show you this on the scope, I got to turn this off. Otherwise you're going to see spikes on the scope from the damn lamp above me. So we shall turn that off. I shall flip on the power. Woohoo! Alright. You can see the scope going wild there for a second. Alright. So this is with everything maxed out. The inputs completely maxed out. Now notice the V meters are not showing anything. I mean, this is very low noise. Barely shows up in the scope until I get my finger next to the coils over here and stuff, which I'll do, and you can see it. My body picks up the noise. See if I can get that on. Yeah. The transistors there too, the switch mode transistors, also introduce noise. Now if I amplified the scope a lot more, you'd be able to see this on the scope. Is it audible? More than likely not. This thing is switching at 50 kilohertz. I think around 50 kilohertz if I recall. But that's one thing I want to shield. So I was testing just a piece of metal, and I'll switch my scope over to math mode here. So now you can actually see the harmonics on the screen. Now I'll switch off this and you'll see the harmonics go away. In 5, 4, 3, 2, 1. Now see, they all went away. Those little spikes. Now when I flip it back on here, you'll see them slowly rise again. 1, 2, 3. Takes a second, and yep, there it is. That big spike right there. I think that's the 50 kilohertz switch mode. Because if I touch the coil again, watch what happens on the scope. Ooh boy, look at those harmonics on the spectrum. Now, I was noticing if I take a piece of metal and just kind of place it over here. Now it doesn't matter if I touch this and ground it out with my hand on the shell. This is strictly from the switch mode. So I like put this plate here. It dramatically reduces those spikes. So the next goal here, let me turn back on my lamp here. And this is why I don't have the lamp on. Because watch this, if I flip back over here, see that? You know what that is? That is because this lamp has a dimmer in it. Watch when I turn up and down the dimmer. And then if I switch off the lamp, it goes away. Turn on the lamp. Yeah. What that is, man, look at all those spikes. That's just from the damn lamp, because it has a dimmer in it. This is what dimmers do. Never have lamps with dimmers in them or fluorescent lighting around your sensitive audio equipment. Granted, this thing is going to have a nice metal shell over it, which will cover all of this, but yeah, that's the stuff you don't hear in your audio, but it's there because of these damn things. And look at, man, they really spike up. Turn it off. Once you know, gone. So that's the idea. The next thing here, I'm going to build a metal shield over there. Is it necessary? Probably not. But you know, why not? As far as the actual unit goes, I do believe is working. Yes. Yes. I mean, I had the gain all the way up, remember? So let me turn this off here. So I was thinking about how I'm going to label the controls, and that was another thing I was kind of wondering about. I built a lot of projects before, but I'd never had one quite like this where everything is so crammed in place. Like, I mean, I even have things on my workbench. Like, this is a power supply I built a long time back. I don't think I actually have a video on this. Damn lamp is... A little 30 volt 3 amp power supply I built ages ago. Used some V meters and made some new labels for them for the amps and voltmeter. But for example, you know, something this big, putting labels on it's clearly not an issue. In fact, this thing only has one label, so. But then we get down to stuff like this, and it's like, well, how am I going to label this? Because this entire panel has got to completely come back off. I got to unscrew everything, which is not that big of a deal. It's going to be time consuming, and all the controls are already soldered and stuff. So I just basically have to, you know, unbolt the potentiometers, the toggle switches, remove those. These are only here temporarily because I'm testing it. But all that stuff has to be removed. Then I have to remove the front panel. I'm gonna sand the front panel down, repaint it. This panel actually was cut off from an old, and I know people are going to get mad about this, but it's an old 5 megahertz Tektronix oscilloscope, the side metal of it. So whatever, you know. The scope is trash anyways. It was junk. So I gotta take this completely off, paint it, and then I gotta put labels on there. And so I had the labels planned out, and you know why I actually have this sheet so perfectly mashed up is because when I put all these controls on here and planned it out, I took a piece of plastic first. Actually, this piece of plastic was the very first thing that was mounted on here. All the controls were originally on this. And so I use this as like a template, basically, before I started drilling the metal. Because when you drill this many holes, you don't want to mess up, you know. It only takes one slip of the drill bit or something like that, and it really mucks up your day. So I built a template, and because I built a template, I realized it's like, well, I can trace that onto paper. And by having the piece of paper, I can redraw the controls and then figure out exactly what I'm going to label it and how I'm going to label them. So you can see here, this is going to be like 8. Well, let's do this. BAN, high Z, toggle switch, 20 decibel pad, phase, damn thing. Gain control, output, infinity symbol, 0 decibel for full output. High pass filter, which I designed for 40, 80, and 160 hertz high pass filter. V meter have yet to determine. I do know I want the orange LED right there to be 0 decibels. Beyond that, I'm thinking 3 and maybe 6 decibels. Below that, I don't know. I gotta figure that one out because the chip I used is not a audio VU chip. It's actually used for other things, so decibel markings might be a little different on my unit, but whatever. Limiter. Well, the limiter, of course, is flipped all the way to the left. It completely turns it off. Otherwise, this is all the release time. I figure I'm going to label release down there, limiter. Master control, we'll have a certain point on the master control where it says 0 dB, so we know that's line level output. Beyond that, of course, it's more. Below that, whatever, mic level, whatever. Let's see, we have the stereo link, and what the stereo link does is when the audio limiter is engaged, when one microphone gets limited, audio limited, it will automatically limit the other one. So without that engaged, each one has their own audio limiter working. However, when you enable that, they work in tandem, so that when one's audio gain, let's say channel B, gets really loud, it'll turn down channel A also, and by doing so, it will not have the stereo tilt effect, they call it. And then, you know, same thing over here. It's just a repeat. B input, high Z, 20 decibel pad, phase, gain, your output level, high pass filter again, and VU meter, and then finally power control. Pretty simple. It's just a matter of getting all these labels on here. It's going to be stuffed. Time to record a test video. I have Audacity currently going here to record. Hopefully I can sync this up with the camera. We have two microphones. We have the right one and we have the left one. And there should be. It is plugged in and it's working. And now, yeah, there's some noise around here. This is right next to a lot of audio equipment, and the top is off of this thing, so of course there's going to be some noise. And plus, I got this thing, which is oddly enough silent through my ribbon microphone, but it seems to travel right into there, through there. So we're just going to ignore that for a minute, and we're just doing a basic test here, right? So let me pick up the right microphone here, and you can hear the audio limiter kicking in. Now see, we have different timing we can use for this, and we can also completely disable the audio limiter by turning this all the way down. So let's do that, and I can really, you know, I don't want to blast the computer away, but you get the idea. Let's turn that up to a decent level. So now notice when I'm talking through this microphone, it doesn't seem to affect the audio limiting of the other microphone. That is what stereo linking does. So let me do a little quick test here. Now what that does, I don't know if you can hear the other microphone in the background, but this one, when I speak loud, cancels out the other microphone also. So you don't get what's called stereo tilt. Same thing. Audio. See, it cancels out the other mic. Now you think, why would you want that? It's useful for stereo recordings so that you don't get audio tilt. It's a thing where with music and stuff, sometimes you get loud sounds through one microphone and the other one is still picking up very loudly. It can sound unnatural, so that's a feature. There's another feature here. It's called mono. So no matter what microphone I speak into, they're equal, as you can see on the VU meters. I can totally turn down or turn off the other microphone and you're just going to hear this one anyway, but you get the point. It's a stereo mic preamp, or you could just look at it like, you know, two microphone preamplifiers in one. We have a low pass filter, so this might sound a little bassy and shaky when I'm holding this microphone. Granted, these are karaoke microphones. Are cheap, you know, $10 microphones, but they're the only identical microphones I have to test with this unit. But just for shits and giggles, let's turn on the high pass filter. Okay, this would be 40 hertz high pass filtering. This would be 80 hertz high pass filtering. This one you probably really notice it on 160 high pass filtering. So notice all the bass is gone in the microphone now. This is useful, so shaking the damn microphone around, you know, you barely notice it compared to this, for example, where it's much more bassy. So I just want to make a quick test video. I'm still recording here, and this is going to be a lot cooler when I actually have the microphones set up properly. Boing, 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 boing. But hey, look at this. She works. Oh shit, I almost forgot to talk about one more thing. Phase. We have a phase switch. So if you flip the phase, let's see if you guys can hear a difference. Let me know if you hear a difference. What that does is it reverses one microphone from the other, or both at the same time. It basically flips positive, negative, negative to positive on the transformer side. That's useful if you're using different microphones and you want to cancel one microphone out from the other, or if you get ground loops and such. Hum on your microphone phase will make a difference. So I'll flip the phase back, and oops, wrong button. Flip the phase back. I'll just go back A-B. Here's phase reverse. Here's phase normal on just one mic. It can be done on both.